11 second t to the 7th over 6 s to the 3rd t to the negative 5th raised to the negative 4th. Okay, so when I first look at this question, I think I want to simplify first. And the reason for that is, if I raise 6 to the 4th power, it's going to be so big, I'm not going to want to deal with it. So I think reducing first is going to be a better choice here, and moving negative exponents. So if I move the negative exponents first, I see that s to the negative 2nd goes down, and t to the negative 5th moves up. So you now have 3 t to the 7th, t to the 5th, over 6, s to the 3rd, s to the 2nd. Notice how the 3 and the 6 did not change at all because they were not raised to powers. And this is all going to be raised to the negative 4th. Now, 3 over 6 are normal coefficients. They just reduce to 1/2. So now you've got 1 over 2. Multiplying t's means you add the powers. So you have t to the 12th. Multiplying s's, again you add the powers. So you have s to the 5th. But this whole thing is still being raised to the negative 4th. So now I have to distribute the power. If I distribute that power, it ends up to look like this. This is going to look ugly before it gets good. So it's going to say 1 to the negative 4th, t to the 12th to the negative 4th, over 2 to the negative 4th, s to the 5th to the negative 4th. I can't really do anything with the coefficients yet, but I can multiply the inner outer powers like that. So I've got 1 to the negative 4th, t to the negative 48th, over 2 to the negative 4th, s to the negative 20th. Okay, that's as simple as I can go right now because of the negative powers. So for me to finish this question, I have to relocate everybody who has a negative power. Now this time, these have negative power, so they will move. So what you end up with now is 2 to the 4th, s to the 20th, over 1 to the 4th, t to the 48th. And then if I do 2 to the 4th, I get 16, because that's 2 times 2 times 2 times 2. If I do 1 to the 4th, I still get a 1. So I end up with 16 s to the 20th over 1 t to the 48th, and your 1 is optional. So if you want, you can take it right out. And there's your final answer for number 11. 2 more. We got this. So 13, we have 4u squared v to the negative 3rd, and then u to the negative 5th, v to the 6th to the 2nd, and then u to the negative 8th, w to the negative 9th. So when I take a look at this question, while it would be nice to move all the negative powers around, I have outer powers, so it's easier for me just to distribute those first, especially because the numbers aren't that big. So for this one, this becomes 4 to the negative 3rd, u to the 2nd to the negative 3rd, and and then v to the first to the negative third. Because remember, when there's no power written, it's automatically a 1. This becomes u to the negative fifth to the second, and v to the sixth to the second. Now these two right here, they don't have an outer power, so I actually could just write them as u to the negative eighth, w to the negative ninth. Now everywhere I have an inner outer power, I have to multiply the powers. So I have to multiply those, multiply those, multiply those, and multiply those. So now I have 4 to the negative third, u to the negative sixth, v to the negative third, u to the negative 10th, v to the 12th, u to the negative 8th, w to the negative 9th. Okay, from here, I'd probably leave the 4 to the negative third for now and deal with the fact that I have 3 multiplying u's, which means I'm going to have to add the 3 exponents, and I have 2 multiplying v's to add the exponents, and then w's out there on his own. So now you have 4 to the negative third, u to the negative 6 plus negative 10 plus negative 8, v to the negative 3 plus 12, and then w to the negative 9th. Okay, so now we have 4 to the negative third. When I add up all the u's, I get negative 24, so u to the negative 24th. When I add the v's, I get v to the 9th, and w has not changed. Not allowed to leave negative exponents in my final answer. So now I have to move all the negative exponents. So right now there is no denominator, but these are all considered numerator parts. So this becomes v to the 9th, who stays on top because it's the only one that doesn't have a negative power, over 4 to the 3rd, u to the 24th, and w to the 9th. Last thing, 4 to the 3rd is 64. So your final answer is v to the 9th over 64, u to the 24th, w to the 9th. That was a little complicated, not terrible. And then we have just one more, number 15, and then you'll be ready to do the evens. I'm almost done.
I'm not rushing you.
Okay, so when I first look at this question, I notice there's no outer powers to distribute. So I can just treat this question like a regular question. So I have coefficients here of 2 and 6, which will multiply to give you 12. A doesn't have any other a's that it's multiplying with, so that's still a to the negative third. You have a multiplier b with b to the 5th, so that's b to the 1 plus 5, because the missing exponent there means it's a 1. And then you have c to the negative 7 all over 4c to the negative 9. 1 plus 5 becomes 6. So you have 12 A to the negative third, B to the sixth, C to the negative seventh, all over 4, C to the negative ninth. Now you take a look and you say, okay, 12 and 4, those are reducible to 3 over 1. So you've got 3 over 1. Now we have to look for who's moving. A to the negative third is moving down, so that's A to the third. B to the sixth is staying right where it is. But your C's are both negative, so C to the negative ninth moves up, and C to the negative seventh moves down. So now you've got C to the ninth, C to the seventh. And then the only